Hi everyone, it's Scorpion Bytes here and I'm happy to welcome you to my brand new YouTube channel. As a short overview, this channel will initially focus on Java tutorials covering everything from absolute beginner level to intermediate and even some advanced topics. After that, I plan to explore other development areas such as Spring Boot and Hibernate, along with some tools like Docker and Jenkins and perhaps even some Linux stuff. Of course, I encourage you all to suggest topics you're interested in, and if I'm familiar with the subject, I'll do my best to create a video about it. With that being said, let's start the first part of this Java tutorial series. In this video, we're going to talk about what is Java. We're going to see how to install IntelliJ IDEA and JDK and what are those. After this, we're going to write our first Java program. And in the end, we're going to see what JVM, JRE, JDK, and JIT are. Okay, so first let's see what Java is. The most important point here is that Java is a high-level, object-oriented programming language, widely recognized for its write-once, run-anywhere capability. As you can see, there are several keywords, so let's start explaining each of them. High-level essentially means that it's easy to write and read and debug, but at the same time we don't have the same hardware access level as compared to C++. But this is generally a good thing because it prevents us from making certain mistakes, and in most cases we wouldn't necessarily need such low-level access anyway. Object-oriented basically means that everything is an object. If you don't know what OOP is, I'll talk about it more in a future video. Write once, run anywhere. Essentially, that means that you can run the same code on different operating systems without changing the code itself. There are also some other good points to remember about Java. For example, it is extensively used for building enterprise-scale application, mobile application and web services. Also, it emphasizes security, reliability, and platform independence. Alright, so I think that's enough theory for the moment, so let's go prepare our setup. We basically need two main things. An IDE, which stands for Integrated Development Environment. This is basically a tool that will help us write, debug, and analyze our code. Also, we will need a JDK or Java Development Kit, which will help us develop the application. More on that in the last part of the video. Okay, so now let's see how to prepare our setup. First, search for IntelliJ. Open the official website. And then click download. Make sure you are under the community edition section and hit download. After the download is complete, launch the installer and complete the steps. Make sure you select the update path variable if you want to be able to launch IntelliJ from the terminal. Once the installation is finished, launch IntelliJ and click New Project. Here, the first thing we need to do is to install a JDK. Click on Download and select any version you want. For those tutorials, I will use version 22. Then, give a name to your project and hit Create. After that, IntelliJ will generate a simple code file for you. Don't worry about the code itself yet, we will get to this immediately. Some parts of the code might be read or some syntax error might be reported, but this is normal. Just wait until IntelliJ finishes installing the JDK and indexing the code. When everything is ready, you should be able to see a green arrow near the main function. Click that arrow and then click Run. If you see the output in the console, you are all set. Okay, so now let's go write our first Java program. Firstly, I'm going to get rid of everything that IntelliJ generated for us. I will only keep the main function and the main class. For the moment, you can consider a function as the group of related statements. I will get into more details in the next videos. As a convention, the main function is like an entry point for every Java application. So, when we try to run the application, the main function is the first that is called by the Java virtual machine. Also, there is a main class. Again, for simplicity, you can think of a class as a container of related functions. I'll get into more details in the next videos. So now let's go add our first instruction. I'm going to print a simple line to the console using system.out.println. Let's run our application and make sure everything is okay. As you can see, the message is written in the console. As I said, you can think of a function for the moment as a group of related statements, so we can print as many messages as we want inside this main function. Let's add another one as an example. So now, as you can see, both messages are written in the console. Okay, so now let's talk a little bit more theory so you can get familiar with 4 abbreviations that are commonly used in the Java world. First, let's see what a Java virtual machine is. A Java virtual machine acts as a runtime engine to run the Java application. It is the reason why Java is considered a write-once run-anywhere programming language, because the code isn't executed by the operating system itself, but by the Java virtual machine. Also, it is the piece of code that actually calls the main method present in the Java code. So if you remember, the main method is like an entry point for Java applications. The Java virtual machine is part of the Java runtime environment. The JRE contains the Java class library, specific tools, and the JVM itself. The JRE is used only if you are interested in running the Java applications and not in creating them. For building Java application, you will need a JDK. A JDK, or Java Development Kit, is a cross-platform software development environment that offers a collection of tools and libraries necessary for developing Java-based software applications. This is basically a toolkit that you need in order to develop Java-based programs. And that's the piece of software we installed in the beginning of this video through IntelliJ. Also, Java environment offers another component called the JIT, or Just-in-Time Compiler. This is a part of the Java runtime environment and is responsible for performance optimization in Java-based application during the runtime. In order to improve performance, the JIT compiles bytecode sequences that are frequently executed by the JVM into native machine code. While using a JIT compiler, the hardware is able to execute the native code, as compared to having the JVM interpret the same sequences of bytecode repeatedly, and so incurring overhead for the translation process. You probably noticed me pronouncing the term bytecode, so let's clarify this. Java bytecode is a set of instructions for the JVM, so basically it is our source code translated into a language that is understood by the JVM. With that being said, let's now try to understand how a Java program gets executed. So every time we press run inside IntelliJ, our source code, in our case main.java, is sent to the compiler. And as you can see, the compiler is part of the JDK. The compiler then compiles the Java file into a bytecode file, or a main.class file. Once the bytecode file is ready, it's sent to the JVM, and it's run. As you can see, the JVM is part of the JRE. When the JVM runs the bytecode, it essentially executes the program, and as a result, you'll be able to see the output in the console. So basically, this process that I have just described is what happens under the hood every time you press run inside IntelliJ. Also, please note the difference between the just-in-time compiler that is a part of the JRE and is responsible for runtime optimizations, or more simple, it has a role in making your code run faster, and the compiler itself that is part of the JDK. Alright, that's all for this video. Thank you so much for watching. If you found this tutorial helpful, please like and subscribe, it would help me a lot. And of course, if you have any questions or suggestions, don't hesitate to drop a comment below. With that being said, keep learning and I'll see you next time.